Assalamu alaikum, dear students of class 9. This is the summary of your today topic, that is factor affecting ionization energy and trends in ionization energy. As we started our chapter number 3, so now today we discuss factors that affect ionization energy, which is on page number 77 of your book. There are four factors that depend upon ionization energy. Number 1 is atomic radius, number 2 nuclear charge, number 3 shielding effect, and number 4 is electronic configuration of the atom. So we discuss these factors one by one. Number 1 is atomic radius of an atom. Okay, atomic radius increase in a group and decrease in a period. When we go from top to bottom, atomic radius is increased because of the addition of electron. As atomic number increase, number of electron also increase. So that is why atomic radius, that is distance between nucleus and the valence shell, also increase. So when distance between the nucleus and the valence shell increase, atomic radius also increase. And we required less amount of energy to remove the valence electron. Right? Here I write this as atomic radius is inversely proportional to ionization energy. Means that when atomic radius increase, ionization energy will decrease. When we go from left to right in a period, there is addition of electrons in the same shell, so atomic radius is decreased. You can see here the size of lithium is large as compared to beryllium. The size of boron is small as compared to beryllium. The size of carbon is small as compared to boron. So when we go from left to right in a period, the atomic size of the atom decrease. So when atomic size decrease, ionization energy also change. So atomic radius is inversely proportional to ionization energy. This is the first factor. Number second is nuclear charge. Nuclear charge is inversely proportional to ionization energy. Means that if the nuclear charge increase, ionization energy also increase. If nuclear charge decrease, ionization energy also decrease. Right? In a group, when we go from top to bottom, nuclear charge is decreased because of addition of electron. You can see here the distance between nucleus and valence shell decrease. Distance is going to be decreased when we go from top to bottom, so we required less amount of energy to remove the valence electron. But when we go from left to right in a period, this nuclear charge increased. Nuclear charge increased because size of atom decreased. Nuclear charge means force of attraction. Opposite charges always attract each other and same charges repel each other. So there is a force of attraction between the nucleus and the electron, because nucleus is a positive and electron is a negative. So this force of attraction is strong in a period because there are electron increasing in the same period. So that is why nuclear charge will increase. When nuclear charge increase, we required more amount of energy to remove the electron from the outermost shell of an atom. Right? Number third effect is shielding effect. Shielding effect increase, ionization energy decrease. There is an inverse relation between these two, as you can see here. Okay, first of all, what is a shielding effect? Shielding effect means when inner electron shield the outer electron from the force of nucleus, from the attraction of nucleus. This effect is called shielding effect. ठीक है? मीन्स दैट कि जो इनर इलेक्ट्रॉन्स होते हैं, जैसे कि हम ग्रुप में देखते हैं कि हमारे पास शेल्स की एडिशन हो रही है, तो नंबर ऑफ इलेक्ट्रॉन्स की भी एडिशन हो रही है, तो पॉजिटिव और नेगेटिव अट्रैक्ट करते हैं, जबकि नेगेटिव चार्जेस हमेशा एक दूसरे को रिपेल करते हैं. तो अब ये जो इनर इलेक्ट्रॉन्स है, दीज आर द इनर इलेक्ट्रॉन. नाउ दीज इनर इलेक्ट्रॉन शील्ड दैट आउटर इलेक्ट्रॉन फ्रॉम द attraction of the nucleus. ठीक है? These inner electron prevent the valence electron from the attraction of nucleus, and this effect is called shielding effect. Now in a group, shielding effect increase. When shielding effect increase, ionization energy decrease because there is a distance increase, nuclear charge also decrease, डिस्टेंस इंक्रीज हो रहा है, ठीक है, न्यूक्लियस में और वैलेंस शेल में, जिसकी वजह से न्यूक्लियर चार्ज मतलब न्यूक्लियस की जो फोर्स ऑफ अट्रैक्शन है वो कम हो रही है, ठीक है, और शील्डिंग इफेक्ट ज़्यादा हो रहा है, मतलब शेल्स की एडिशन हो रही है। जब शेल्स की एडिशन हो रही है मीन नंबर ऑफ इलेक्ट्रॉन्स की भी एडिशन हो रही है, इस वजह से आयनाइजेशन एनर्जी क्या हो जाएगी, डिक्रीज हो जाएगी। मीन इफ़ यू वांट टू रिमूव दिस वैलेंस इलेक्ट्रॉन देन वी रिक्वायर less amount of energy to remove this valence electron, right? And the fourth one is electronic configuration. Completely filled and half filled orbitals are more stable, so we require a more amount of energy, right? Okay, what is completely filled and half filled orbital? First of all, we know that we have a K, L, M and N shells. We divide the shells into subshells, that is S, P, D and F. In a K shell, only S subshell is present. In a L, S and P are present. In a M, S, P, D subshells are present, and in N shell, S, P, D and F subshells are present. So, nature of orbitals also affect the ionization energy. As S subshell is close to the nucleus, so we require a more amount of energy to remove the electron from the S subshell. Then P subshell is far away from the nucleus as compared to S subshell. There is a distance increase in a P subshell, so we require less amount of energy to remove the electron from the P subshell. If we want to remove the electron from the D subshell, then we require less amount of energy as compared to S and P subshell, because there is an increase in the distance between the nucleus and the D subshell. And if we want to remove an electron from the F subshell, then there is also decrease in energy, because F subshell is far away from the nucleus. As you can see here, S is the first subshell, it is close to the nucleus, and F is the last subshell, so we require less amount of energy to remove the electron from the F subshell. And next thing is completely filled and half filled orbitals are more stable. As we know that in the S subshell, two electrons can accommodate. If S subshell contain only one electron, we call it incomplete or half filled orbital. This is also stable. S subshell contain two electrons, this is stable, right? P subshell contain maximum of 6 electrons. This is the stable. So if the P shell contain 3 electrons in their shell, this is incompletely filled or half filled orbital. We can also say that partially filled orbital. So completely filled orbitals and half filled orbitals are also stable, so we require a more amount of energy to remove the electron from these orbitals, right? Okay, now the next one